Alright, so this is going to be objective 32. We are going to apply properties of logarithms. So properties of logarithms remind me of our properties of exponents. So we're going to kind of be comparing the two. They'll be very similar. Okay, so let's just review what we've already done, and I actually need to change the directions. This should be exponential form. So, because I've given it to you in logarithmic form, so if we review log base 5 of s equals r, if we took it to exponential, it would be 5 to the r equals s. If we did log base 2 of 1/8 equals -3 and wrote that in exponential form, it would be 2 to the -3rd equals 1/8. Okay, so just reviewed, this guy right here is your exponent. This is your base. And we call this the outcome. Okay, so let's look at this part. We're going to make this into logarithmic form. So 2 to the 3rd equals 8. So if we wrote that as a log, it would be the log base 2 of 8 is equal to 3. Okay, again, just a good review. And this one would be the log base 10 of 100,000 is equal to 5. And we're going to go a little bit further. We talked about this the other day. When it is base 10, you don't necessarily have to say base 10. You could just say the log of 100,000. And we talked about this in your calculator. You can use your math, alpha math. So if you press math, alpha, math, that will give you your log base key, and you could put that in. Or if you go down on the left-hand side and you just use the log key, you can put that in. So when there is no base, you can use the log key. That just means base 10. Okay, that just means base 10. So when there is no base, it does mean that there's a base 10. So let's expand a little bit more on that and look at our properties. So the log base a of 1 is equal to 0. If you wrote that in exponential form, it would say a to the 0 power is equal to 1. And we understand that. We know anything to the 0 power. So just when you have the log base anything of 1, that's always equal to 0. Just the opposite of that. Same thing here. Log base a of a is equal to 1. And that makes sense to us because a to the 1st power would equal a. Okay, so anything, if the bases match, that means it's going to be to the 1st power. Okay, the log base a of a to the x, basically you're combining a log with something in exponential form, and when the bases match, you're doing two opposites, so they will cancel, and you'll just get x. You just get the exponent. Okay, and if you reverse that, if you take, this is written as an exponent but has a log within it as well, again, the base here matches the base here, they will cancel, and you just get x. Okay, so when you do two inverses, they will cancel each other out. And the inverse of a log is an exponential, so they will cancel each other out and just give you x. Okay, so using our properties of exponents, the log base 5 of 1, so what will give us a 1 as an outcome? Anything that is raised to the 0 power. Okay, the log base 5 of 5, what will give us an outcome of the same thing? Anything that is raised to the 1st power. The bases match here and the bases match there, so the bases can cancel, and it just equals 8. And Same thing here. You have an exponential, a log within an exponential, and the bases match, so they will cancel, and it'll equal 12. All right, so just kind of a rule of thumb, the common log, it is the log of x, that is understood to be base 10. So when there is no base, it's understood to be base 10. Okay. I also want to introduce to you the natural log. The ln of x is equal to log base e of x. So we know e is that fancy dancy number. E is equal to 2.71. Can't get anything to write today. 7 1 218 7 1 2.71828. Okay, so when I'm talking about the ln, that just means I'm referring to a base e. Okay, it's called the natural log. All right, so our properties. So the ln of 1 would equal 0. And so if we wrote that out as a log, this would be log base e of 1 equals 0. And that is an exponential. E to the 0 power would be equal to 1. It doesn't matter if it's 5 to the 0 power, x to the 0 power, e to the 0 power, it's still equal to 1. Okay? The ln of e, if we wrote that as a log, it would be the log base e of e to the first, and that would be equal to 1. So they will cancel, and it just equals 1. Same thing here. The log base e of e to the x. So those will cancel, and it just gives you x. And the ln and the e, this is e to the log base e of x. So those will cancel, and it just gives you x. Okay, so the ln of e to the 8th. So another way to write this, if you don't understand, ln and e will cancel each other out. But another way to write this is the log base e of e to the 8th. So the bases match, so they'll cancel. It gives you 8. Okay. Another way to write this would be the ln of e to the negative 2. We know the ln and the e will cancel, and it just gives you negative 2. And then the ln of 5, that's log base e of 5. There is no shortcut for that one. So that one you will just have to put into your calculator, and you can put in the ln of 5, and I believe it gives you 1.609, and you can just round it there, 1.609. And basically what that means is e to the 1.6, if you raised 2.7128 or 71828 raised to the 1.609, you would get somewhere around 5. It's not going to be exactly 5 because it's a decimal and we rounded it, but it would be like 4.99999. It would be really close. Okay, so you can use your ln, and then you can use your log base. You can use your math alpha math, and then just put in log base e. Okay, so there's our practice for today.